when you do an integration and go, and it's in terms of x, your function is in terms of x, and you put dx, you're integrating with respect to the x-axis. Now, we don't just find areas enclosed by the x-axis, we also find areas enclosed by the y-axis. So instead of function of x dx, substitute in the x values. When you're integrating with respect to the y-axis, we do function of y dy, and we substitute in y values. Okay? So for this, area enclosed by y-axis, to find the area between a curve and the y-axis, you must change the subject of the equation of the curve to x. You know how normally you've got y equals function of x? Normally we've got y equals function of x. Well, we want the opposite. We need x is a function of y. So we make x the subject of the formula. And then if x is the subject, everything on the right-hand side of the formula is y's. Okay? So therefore, the definite integral between the y values of b and a, when the function is in terms of y, is, it's the integral between b and a of the function of y dy. Or I've written or the integral between b and a of x dy. Why did I write x? Because x is a function of y. But learn it this way. So it means the other formula is b and a y dx. But just learn it as function of y dy or function of x dx. So if you are integrating, just looking here, look back at what we did. I integrated this, x squared minus 9 dx, right? The first one was 1 minus x squared dx. Do you get it? That's all in terms of x. Integrate with respect to x. This question here was 3x squared. Integrate 3x squared dx. All in terms of x, integrate with respect to x. But now with y's, we'll do our first example. In a minute. Now, if I was to, so you're actually finding the area bound by the curve and the y-axis. Now, you know the x values along here are positive. If I turned it around like this, on this side gives me positive answers for my integral. But if my area was down here, I'd get negative answers. So you just turn it sideways to make the x-axis look like the old y-axis. All right, so that is the positive side of y, and that would be the negative. On the right is positive. You know, like normally up is positive, down is negative. On the right of the y-axis is positive area. On the left of the y-axis is negative area. So if I were to find this, find the area bound by the y-axis, the curve x equals y squared, and the lines y equals 0 and y equals 4. Well, you're going to have to draw that, and you may not know how to draw it. So what would you do? You would do a table of values. Now, we need to know it between the lines y is 0 and y is 4. So you're going to have to work out when y is 4, right? What are you going to put your x value as? Well, what about when y is 4? What do you get for x? 16. When y, so I need values of y. Look, you could do, normally when we do a table of values, we put x first and then y. But even though the function's the other way, it still will be okay, because when y is 0, isn't x 0? What about when y is 1? What's x? 1. When y is 2, do you know why I'm choosing y is 0, 1, 2, 3, 4? Because I need to sketch it between the lines y is 0 and y is 4. When y is 2, 2 squared is 4. When y is 3, 3 squared is 9. So what I've done is just plotted. Right, I've got 16 about there. It's not anything accurate. I've got 0, 0, 1, 1. When x is 4, y is 2. When x is 9, y is 3. When x is 16, y is 4. So when I integrate this, my area is the integral between 4 and 0 of y squared dy. So what do I get? Y cubed on 3. See, I'm substituting in y values. That's all in terms of y, and it's dy. So I integrate, substitute y is 4 and 0, do the substitution, and I get 21 1/3 units squared. See, you know how we said you need x as a function of y? I do have x is y squared, so x is a function of y. You know how normally it's y equals something, x, whatever? As long as the x is out the front, you'll substitute this side. That's your function in y. But this question here is a bit different. Find the area enclosed between the curve y equals x squared, we know looks like that, the y-axis, which is here, and again the lines y equals 1 and y equals 4 in the first quadrant. Now, this is y equals x squared. This is not x as a function of y. I have to square root both sides. I have to change the subject of the formula to x. Because you know in all our other ones, y was equal to this, y was equal to that. Now I've got to have x equals this, x equals that. All right, because everything's swapped. So I've got x squared equals y. I can't use that. So I've got a square root. Now we know that when you square root, you do plus or minus, but I know it's the positive one because these are all positive values. Look, when x is 1, y is 1. When x is 2, y is 2. So change the subject of the equation of the curve to x. So you have to square root both sides. So x is the positive square root of y. So if I want to find this area, it's the integral between the first y value and the second one, the higher one first, then the second one, of the square root of y dy. Now the square root of y is y to the power of a half dy. Are you okay with this? Because you just got to think of the other one was y equals x cubed, x squared, whatever it was. This has to be x equals anything of y, all right? So then you integrate by raising the power by 1 over itself. You do your substitution, and we got 4 2/3 units. Okay, now, looking at the next one, there is no way, look at it, y equals square root of 3x minus 5. I have to integrate it, and I need the area enclosed by the y-axis and the lines y equals 2 and 3. Well, you know what? I know that that is a part of a parabola. How do I know? Let's say you start with that. If you square both sides, you get y squared is 3x minus 5. If I take that to the other side, you know, I cannot do this question unless x is the subject. You know how x is a function of y? So I look at this and I say, I've got to make the subject of the equation x. So I square both sides. It'd be a good idea if you recognize a parabola as well. That's half a parabola. This is a parabola. But this is a sideways one, not an up and down one. Because you know y equals x squared is a normal parabola. X equals y squared type are sideways parabolas. If you're not sure how it looks, you could substitute some values and sketch it. Okay, so we've got to make x the subject. And now we can integrate. And we're going to put in the y values of 3 and 2. Okay? Now I did a quick sketch of this curve because I knew if I put x is 0 in here, I get, when x is 0, I want between the values of y is 3 and y is 2. If I put y is 3 in here, and I square both sides, 3x minus 5. See, if I put y is 3, I get 3 is the square root of 3x minus 5. How could I solve that? Square both sides. 9 is 3x minus 5. 3x is 13. X is 13. So it's about 4-ish. Yes, I did. So that's 14. 14 on 3. That's almost 5. So when y is 3, I'm getting approximately 5. So that's why I've got that point. When y is 3, x is approximately 5. And when y is 2, I get, what would I do? Square. What do you get? 3x is 9. X is 3. When y is 2, x is 3. That one's 5, roughly. That's why I'm getting that, guys. And I don't know what's happening with the rest of that. Anyway, look, it does. Look, whether it goes like this or whether it goes like that, I don't think it's going to matter. The thing is, for those two values, the x's are over here, so the area is like that. I just did a quick, maybe it actually probably looks like this, all right? So it doesn't matter. So what I do to be able to integrate, at least this is x is a function of y, I can now integrate. Are you okay with that? So let's have a look. Guys, so x is a function of y. The area is the integral between 3 and 2 of that function in terms of y dy. You integrate and do all the substitution and you will get that. Notice in most of these questions, when you are finding the area enclosed between the curve and the y-axis, you have to find the area enclosed between the curve and the y-axis. It's not in a form that you can integrate. You have to make, for example, here, x is not the subject, it needs to be made the subject. So you'll take the 2 over, find the cubed root. Cubed root is power of a third, and then you could integrate. But we have to know the y values, and it says to integrate between the y-axis and these y values. Now, you're going to have to do a quick sketch. It's okay that it's under the line here, but as long as it's all on this side of the y-axis. And you just substitute in your values and do your integral. Main thing here is change the subject.